Let's look at another example here that doesn't seem to fit the pattern of a trig substitution. We see here x squared plus 2x minus 3 underneath that square root. We'd like to see, x squared minus 4 or something like that, x squared plus 4. So what we need to do with this is complete the square in order to get a difference or sum of two squares. So we've got integral 1 over square root, and then remember to make a perfect square there. What we want to do with the x squared plus 2x is take that middle coefficient there, divide it by 2, and then square that value. So 2 divided by 2 is 1, squared is 1, and that's what we need to add on the end here. So plus 1, and then we've got that minus 3, and then you can't just add 1 without compensating because that changes the value of the expression, so we have to subtract it back out again. So I'm completing the square here, and dx. And now this quantity underneath the square root is, so you got square root, and then this piece right here is x plus 1 quantity squared. It's x plus 1 times x plus 1. So if you FOIL backwards on that. And then we've got a negative 3 and a negative 1 is a negative 4. So now we do have a quantity squared minus a number squared. And dx. So now this looks like secant squared minus 1. Secant squared theta minus 1 is the trig identity that's closest to. We want to match up the numerical parts here, which means we need to multiply through by 4. So this will be 4 secant squared theta minus 4. So now the constants match up, so that means that x plus 1 squared has got to equal 4 secant squared. So taking square roots on both sides, then x plus 1 has to be 2 secant theta. And bring the 1 over as a negative. X has to be 2 secant theta minus 1. So then dx is going to be 2. Derivative secant theta is secant theta tan theta. Derivative of negative 1 is 0, and then times d theta. So now, what's underneath the square root is 4 times secant squared minus 1. So this is integral 1 in the numerator, square root 4 times secant squared theta minus 1. And then our dx up here, 2 secant theta tan theta d theta. And now let's go ahead and simplify as much as we can. So secant squared minus 1 is tangent squared, so this is really 1 over square root 4 tangent squared theta times 2 secant squared, or I'm sorry, secant theta tan theta. And then square root of 4 is 2, square root of tangent squared is tangent. So this is 1 over 2 tan theta times 2 secant theta tan theta d theta. And then tangent thetas cancel, 2's cancel. This is just the integral of secant theta. And remember, that's one of the ones that we had the formula for in the last section here. So that's this formula here. Integral of secant is natural log secant plus tangent. So this will be natural log absolute value, secant theta plus tan theta, and then plus our constant. And now to wrap things up, we just need to change back from theta to x here. And in order to do that, we need our right triangle. So here's our angle theta. And we want to use 2 secant theta is x plus 1. And solve that for secant theta. So secant theta is x plus 1 over 2. Secant's 1 over cosine. Cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. So hypotenuse is x plus 1. Adjacent is 2. And then this side here is going to be square root hypotenuse squared, x plus 1 squared, minus leg squared, 2 squared. But that x plus 1 squared minus 2 squared, that's what we have right here. That's what's underneath the square root. In fact, that is equivalent to our x squared plus 2x minus 3 before we completed the square. So that's our double check that we did things right. And then to wrap things up here, so we'll have a natural log. Absolute value, secant theta is x plus 1 over 2. Plus, and then tan theta is opposite over adjacent. So this will be our square root of x squared plus 2x minus 3, which is this one simplified. And then divide by our adjacent of 2 and plus a constant. And we've got it. So that one was a little bit more involved with completing the square, but on the end here, our integral, we didn't have to do any substitutions to find that integral. We just used the formula.